Okay, thank you everybody for joining. We have a few more folks dialing in just right now, but I'd like to thank all of you for taking the time to join us today. It's really exciting to be here at Tempered at this time because the innovation we're going to be talking about, quite frankly, has never been done before. And the whole purpose is to enable dramatic simplification in networking and security and making things secure by default when we're connecting things. The outcome is ultimately what we refer to as wide area microsegmentation, which quite frankly has never been done before, that is not only simple, but it's boundaryless. So let's get started. We'll go over the agenda real quick, but the whole principle here is we've got a lot of our customers on the phone that are getting this update around us, this new launch, this latest release of our product, but also we have a lot of new attendees, people that aren't yet customers of Tempered. So I'm going to do a little bit of a background on what's so fundamentally different about Tempered's approach and identity-defined networking in general. But then really focus on the use cases of what this enables based upon what our customers have experienced. And if we have time, we'll also move to a demo and then also how to get started. The fundamental principle, what we're all about, and our vision is what is often referred to as, Internet 3.0. which is fundamentally the notion of only networking provably identifiable things. As all of you well know that have been in networking and security for quite some time, TCP/IP itself was all focused on end-to-end networking, connecting one thing to another. And we're in this age right now, especially with IoT, where we're networking everything. And we know that with every new thing that's being networked or connected, that not only adds additional complexity to the environment, but also vulnerabilities. It increases our attack vectors exponentially. When we move to a model of only networking things we know and we trust, we start to change the game. And it serves as the foundation that enables things like wide area microsegmentation that is, in essence, borderless or without boundaries. And we'll get into that quickly here. But as you well know, we started out with end-to-end connectivity, but over the years, out of necessity, networking and security products had to introduce new technologies, new functions like network address translation to overcome the limitations of IP. We had to introduce, firewalls for security purposes and VPNs for remote access and access control lists for defining which network could connect to which network under which conditions. And then as we entered and added new environments and new networks and even entirely new constructs like cloud, we have complicated the environment so much it's become pretty much unsustainable. And it's no wonder that that original intent of TCP/IP itself, which was end-to-end networking, has become next to impossible. We have all of these barriers and roadblocks in the way, but imagine if these barriers and roadblocks were easily overcome, that I could, once again, connect any endpoint to another, regardless of its IP address or not. And this is one of the fundamental principles of identity-defined network and what Tempered Networks is all about. We fundamentally believe address-defined networking as it's done today, which is really how we define policy based on an IP address as identity, is simply not sustainable. And we know with every add, move, or change, the math proves that it's exponentially more complex and also insecure. The way forward from this old model that, based upon the OSI stack, that really hasn't been updated since the early 90s, is a new approach based upon the HostIdentity Protocol as its foundation. The HostIdentity Protocol, which I'd encourage all of you to read the RFCs, is, think of it as layer 3.5. This ability to assign identity, unique cryptographic identity to every connected thing. If we do that, now we put IP in its original role as location and not serving the dual purpose of identity and location. This also gives us a tremendous amount of flexibility, which we'll get into and will prove when we show our use cases. So the concept, again, is moving from an address-defined environment that, in essence, can't be trusted because addresses and fundamentally are spoofable, to something that is trusted because every connected thing is based upon a unique cryptographic identity, where we bind the identity, this cryptographic identity, to the host. And it's very simple to deploy, manage, and create these trust relationships, overcoming all those roadblocks and barriers we were talking about earlier. So the construct of Tempered's approach, overcoming these barriers and boundaries and impassable borders that don't necessarily make us more secure, is centered around the orchestration of policy, trust-based policy, that gets distributed to every identity-defined network enforcement point. In our world, the way we refer to that are what are called HIP services, Host Identity Protocol services. And they come in a variety of forms. They come in the form of a cloud appliance, a virtual appliance, a physical appliance, and even software on a client or on a server. And the whole point here is everything is symmetric. So in this diagram, if you have devices that where you cannot install software, sitting in front of it, acting as that enforcement point that will cloak and protect that device, is a HIP service, whether physical or virtual or otherwise. When policy gets distributed and you explicitly say, based upon a whitelist, this device or group of devices or systems can talk to these, that is an inviolate trust policy. It cannot be subjugated or broken by any other thing. Because, and this is the fundamental principle, and I'm going to go back to this diagram here really quickly. The machine authenticates and authorizes itself to another, to a trusted other, before transport is established and any data exchanged. This is what gives everything cloaking and the inability for a hacker to discover that system. It also enables global IP mobility, especially now that we're introducing the new HIP relay, which is the world's first identity-based router. Now I'll get asked this question. So is this like a traditional router? No, because we're using crypto identity in order to determine and authorize whether or not we should forward those packets to a previously non-routable endpoint. What the HIP relay does is not only provides a much stronger security posture and ability to isolate based upon provable identity, but it can now overcome previously impassable barriers or borders. Things like carrier-grade NAT or multi-NAT environments, or connecting a cellular network, say AT&T, a device on an AT&T network, to something very deeply and privately addressed on a Verizon network, or coming from a public Wi-Fi. What in essence we're doing is very similar to what Google has done with BeyondCorp. In essence, being able to create very discrete micro-perimeters, even down to a perimeter of one. We're moving the network security and the network edge, the security from the network edge, down as close to the host as possible. Again, the whole principle of the HostIdentity Protocol. What the HIP relay enables and what HIP in essence does is it creates a new host identity namespace. It's completely compatible with the IP namespace and DNS namespace we're all familiar with today, but it's much more trustworthy and it dramatically simplifies everything. In this example, and I've got this as a more detailed use case as well, things like inter-cloud peering or region-to-region peering between resources and on-premises resources that is very discrete, meaning instance-to-instance level or device-to-device level, now becomes not only possible, but extremely simple and practical. It is secure wide area microsegmentation. And I'll show you how simple it is to implement. But first, I'm going to explain a little bit of the magic behind the HIP relay and identity-based routing. The first step is to deploy our HIP services. And in this diagram, they're in the form of software that would be installed on a client and software or a appliance that would sit in front of a protected server over here on the left, and another client. And these clients could be coming from anywhere. The HIP relays, you'll notice, are the only publicly addressable element in the secure networking model here. The deployments usually take under a few minutes. It's rather trivial to do. But once the conductor or orchestration engine, and you set policy, and I'll show you what's setting policy and how simple it is to do, you set the trust relationships. The conductor distributes that policy out to all the connected endpoints, and now you've got established trust. And these endpoints will register themselves outbound to the HIP relay or a cluster of HIP relays, and the HIP relay learns and says, yes, this is a trust relationship that is allowed. When a user wants to then connect outbound, it knows to go to the HIP relay, and the HIP relay knows, oh, I have a trust relationship, and that protected system on the left also is registered in the HIP relay, and the two now can set up an encrypted tunnel end to end, overcoming any type of previously impassable network barrier or borders. So we're delivering secure, very discrete microsegmentation across wide area without boundaries or borders. So let's get into some of the use cases. This was an interesting one of our customers who had a need to protect very sensitive information that should be only accessible to their board of directors. This server here on the left. And they have the typical environment of users, their board of directors. They couldn't anticipate which network or where they were going to be coming from at any given time. They needed and they established requirements that said, we want strong encryption end-to-end, whether the board of directors are coming from the wide area or the internet, or they're on the LAN. We need to ensure that we have authenticated, always authenticated and authorized access, not just at the user level, but at the machine level, machine authenticated and authorized access. So think of that as kind of when you mix that with identity and access management, user-based, it's like automatic two-factor authentication. They also wanted to ensure isolation and microsegmentation of that board of directors server. You'll notice over here on the left still, it is a non-routable address, but it's on a shared subnet where there could be other devices. They didn't want anybody in the LAN to be able to discover this system, so that if something became compromised on the internal network, that the board of directors server would not be discoverable by a bad actor. And of course, they needed access from everywhere, and they wanted consistent enforcement, whether the board of directors were, again, coming remote from anywhere, or whether they were at corporate headquarters and for their board of directors meeting, without having to change the underlay network or any of the policies and access control lists or in be managing certificates, et cetera, et cetera. So what do? Well, they looked at alternatives like using next-gen firewalls and VPN technology, but those weren't always going to be accessible from anywhere, and they had to burn a public IP for those things. They also wouldn't be consistent, whether it was from remote or on the local area network, and also that resource wouldn't necessarily be, that board of directors server wouldn't necessarily be cloaked and protected and undiscoverable by anybody else in the company. The way tempered networks works and our orchestration engine of policy is very simple. This is a big part of our overall value proposition, is it enables IT to do more with less. And it's very simple in its approach. What you see here on the left is every HIP service registers itself to the conductor once it's deployed, and you accept or grant it access. But it has access to nothing until you explicitly define what group of things or individual thing it has access to. And in this case, I've got my board of directors clients and the web server, and I simply select the web server and the radio buttons associated with all of these protected endpoints, and I've created now a trust relationship. But this is where the new HIP relay and identity-based routing comes in. To enable access from anywhere, encrypted, wide area micro segmentation from anywhere, the HIP relay policy, and it's simple to create this rule to say this group of endpoints can talk through this relay, and you select the relay that's been set up, and setting up a relay takes under a few minutes. And now I've got the ability where those, as part of that policy now, though my board of directors users have access via secure access via the HIP relay that will authenticate and authorize forwarding the packets on, regardless of whatever network this board of director user is coming from. And remember, all of it is based on a unique cryptographic identity that is not spoofable. So I've got also not only the protections, the only things that can talk to the board of directors server are those that I have authorized, those machines that I have authorized. So what I get is, this is an example of our visual trust map that shows you the relationships, the trust relationships of the, in this case, a hub and spoke of the clients to the board of directors server. And what's interesting about this, and I'll remind people that all of these devices, you'll notice the IP addresses here, all of them were previously non-routable. I did not have to do NAT. I was able to overcome any NAT barriers or carrier grade barriers, regardless of where the users are from. And I've got explicit access that is trust-based, and that I know no other device will be able to access this board of directors server or even see it because it won't respond. And now keep in mind, I mentioned this earlier, part of the underpinnings of the HostIdentity Protocol is, remember, you authenticate, the machine authenticates and authorizes before TCP, before transport is established and any data is exchanged. If the right cryptographic identity is not presented, it won't respond. If the right cryptographic identity is not presented and the four-way base exchange is not valid, it won't connect. So it creates this type of unbreakable segmentation that previously was not practical or possible. And now with the new HIP relay, we can overcome all the previous networking borders and barriers that were impassable, that made end-to-end connectivity impossible. And it can be done in as little as 4 simple steps. Think about the alternative of trying to do something that wouldn't even be remotely close to this. A combination of firewalls, NATing, VPNs, VPN clients, access control lists, certificate management, all these other things that would make this pretty much untenable and certainly wouldn't make it practical to apply consistent policy regardless of where those clients were coming from, whether it was remote or on the local area network. The beautiful thing about this too, as simple as it is to set up and establish this wide area microsegmentation, it is as fast, if not faster, it's faster actually, to revoke. It's one click and that machine will be revoked. So for example, if I were to revoke one of my board of director clients right here, even if their password and username access was still valid on the board of directors server, but I revoked their machine, it wouldn't matter. They would not be able to get in. Our customers tell us the value proposition here in overcoming the problems around adequate controls and updates for identity and access management become greatly simplified when combined with identity-defined networking and one of the key outcomes, wide area microsegmentation. The other beautiful thing about this is once policy is set and the encrypted packets are flowing between the board of directors server and the client via the HIP relay, it traverses the underlay network with no modifications as any encrypted packets would. There is very little overhead to adds, moves, or changes when we're talking about identity-defined networking versus the address-defined approach of defining, this IP coming from this network needs to be translated to this address to access this network, et cetera, et cetera. That previous example that I said was unsustainable. So when we look at the primary objectives that they set for themselves of end-to-end encryption from the board of directors server all the way to the client to completely authenticated and authorized access. Keep in mind here too, this is the brilliant thing. I'm not having to chase down logs in my VPNs and my firewalls and on the web server. I can see directly here who, what, and when was accessed. And this is all exposed as well as in our API for integrating into SIM systems and things of that nature. So not only is it everything authenticated and auditable, but we've got complete isolation, cloaking, and microsegmentation with access from anywhere, and the same policy, whether the user is coming from the wide area to the local area, it will be enforced. And here's the beautiful thing too about the underlying technology and our ability to orchestrate this, is that once a user in this scenario is on the local area network, for example, they're not going back out to the relay. The HIP services know where the nearest hop is and that there's a HIP service internal on the same network or on the same LAN. So we'll direct connect there. So not only do we ensure that we're providing the isolation and segmentation, but we're also, in essence, directing the resource, the machine to the other machine or the user to the other server to the closest next hop. So that's one of an example of use cases. We have other customers that are applying this to other sensitive data, whether it's HR systems or financial systems or even database teams. And again, this is incredibly simple to implement. In fact, most of our customers, when we run a proof of value to show how we go about doing things in the identity-defined networking world at a customer site, it usually takes us under a few hours to implement, and most of that time is spent on just talking about the architecture and the placement of the technology. The rest is we spend talking about the best way to manage and set up and orchestrate policy definition. But like I showed you earlier, it's very, very simple to do. So let's move on to some other previously impossible or impractical use cases. When it comes to cloud, there are a lot of limitations that people that are in DevOps are very familiar with. One of them is the practice of peering between clouds. In AWS, which is a fantastic platform, however, they have limitations that are brought on not because of their inability, but because of the limitations of address-defined networking in general, having to do policy based upon, IP addresses and for things or networks. In this case, you cannot peer between resources in the cloud and on premises unless, on the left here, if you're using a VPN or AWS Direct Connect. It's one of the limitations. With Tempered, it's easily overcome. We're not restricted by connection peering limits or the number of public addresses or available or not, because remember, we can route previously non-routable IP. And it doesn't matter what the schema, the IP schema is. We can overcome this example. Here's another one where when it comes to VPC peering, you cannot connect and peer between regions. You can only do limited VPC peering within the same region. Well, when it comes to Tempered, there is no boundary. We can do edge to edge or even instance to instance peering. And regardless of the IP scheme. In essence, the cryptographic identity is abstracting the IP address from using the IP address from the wide area perspective. The IP address is only used for location on the local area. And that is controlled by the HIP service itself that is determining where that thing is that is sitting behind the HIP service. So this enables things like seamless workload migration. We've had several industrial enterprise customers that wanted to leverage IoT data in the cloud and couldn't because of IP conflicts. IP conflicts now go away. And although I'm using the cloud as an example here, keep in mind the same principle applies whether physical, virtual, or on-premise. This is what we refer to as global IP mobility, overcoming all the address name constraints. And that is enabled by the host identity namespace, which is networking only provable cryptographic things, identifiable things. In this example, this was fascinating. I was talking to one of our customers who has a pretty large presence in the cloud, and they wanted to leverage some services in Azure, as well as they were primarily in AWS, as well as migrate a few workloads between them. When you go on to Azure's support site and forums, they have some examples of ways to accomplish this, but they're not very attractive. And then again, it's not a limitation of Azure or AWS per se. It's really a fundamental limitation of address-defined networking or basing policy on IP addressing. In this example on the left, it required 3+ products and 150 different configuration steps and changes in security groups and policies in AWS just to connect edge-to-edge network to enable workload migration. And again, it's just edge-to-edge. It's not instance-to-instance type of segmentation and granularity. And it's also not based upon provable cryptographic machine identities. In our world, and what wide area microsegmentation, along with the HIP relay, enables is the ability to, in essence, create an environment that could look like a layer 2 network or a layer 3 network, and you can bind all these things together in the steps. It can take less than just a few clicks. And as simple as it is to network these distributed elements across clouds, irregardless of the IP schema, and it's point-to-point encrypted, now I've got incredible flexibility to create new types of DR scenarios, to leverage different clouds without constraint or restriction, putting me in control or you in control instead of the cloud provider. So what does this type of magic take to set up? It's very simple. Once a service is defined, and again, to deploy our in a tempered networks HIP switch in AWS, it takes maybe under 5 minutes to set up, and that becomes your identity gateway to those resources and also the enforcement point. And you do the same thing in Azure. And you define then what local services are sitting behind that HIP service, what local instances or things you want to network, and whatever their IP address is, it auto discovers that. Setting up trust relationships is as simple as what I showed you in the board of directors example. You select the service or the instance that you want to connect and be trusted to others, and you select those that you want it to talk to, as well as which HIP relay, identity-based router, to use. And what you end up with is something like this, a true cloud peering mesh that can be as specific and granular as you want, or in groups of users. But in this case, I'm showing instance-to-instance connectivity that not only spans clouds between AWS and Azure, but even between regions, AWS in the EU and in the West. And the same is true for my DevOps users. If you know cloud at all and you work in cloud, you'll know that it's more common than not that getting access to instances in the cloud, I'd say a majority of DevOps don't use things like VPNs because of the complexity and their inaccessibility depending upon where they're coming from and the difficulty of maintaining those policies and certificates. But they actually do SSH and share keys among themselves. It's not terribly secure. But by being able to creating what is in essence a common broadcast domain, network domain spanning these clouds, we not only allow instance-to-instance VPC peering, but also very discrete and auditable DevOps remote access from anywhere. They could be coming from a public Wi-Fi, they could be coming from the corporate network, they could be coming from home, they could be coming from a cellular network, cellular hotspot. The result is not only it's simple, but it's extremely cost-effective and efficient, and it's auditable. We start to eliminate technologies and the overhead of maintaining public IP addresses and NATing policies and multi-NAT environments and address-defined firewall rules that really aren't terribly effective because they can be spoofed and traversed. And we're in essence creating a unified architecture that enables global mobility without constraint. So hopefully you're starting to get a picture of what this can mean for your environment and why we're such big proponents of the host identity protocol in and of itself, but identity-defined networking and what wide area microsegmentation can mean. A big part of our overall roadmap and philosophy has been to enable the host identity protocol to be deployed everywhere. It is an open standard. It was recently ratified in 2015. It's been in production in the military and industrial enterprises since 2006. Tempered is the first company to commercialize this, and we've been selling product and have a very rapidly growing customer base since about 2012. This is going to grow unabated because it is the only way forward. One of the limitations, or one of the things about HIP, is that we're the only ones that have made it available to be deployed at almost any client, server, or industrial enterprise IoT, so that you can have a unified fabric that knows no boundaries. And the special sauce is being able to easily set and create and audit and orchestrate policy to all of these distributed endpoints that know no boundaries. And increasingly, we have partners in the networking world, especially industrial networking world, that want to embed our software in their own platforms. The code is very lightweight and can be run in something as small as a Raspberry Pi. It's incredibly powerful, and this is why we believe it's the future of the internet to enable Internet 3.0. Now, as I sum up here, it's really important that folks understand that the traditional networking architecture does not go away. It just plays a role that it's better suited for, which is getting a packet from point A to point B. And all these roadblocks and barriers that have been put in the way to try and secure and extend IP addressing and all those things that now make it so difficult for us becomes much simpler. And so when we talk about orchestration and the simplified orchestration, we're not only talking about our ability to simplify, but the underlay network becomes much simpler. We are no longer over-relying on maintaining router access control lists or access VLAN access control lists or complex inbound firewall rule sets. Again, because now I'm able to directly connect and route what was previously not routable, very deep inside the environment, and do end-to-end encrypted connectivity. That's what gets us this global IP mobility, and the fact that we authenticate and authorize machines before they can establish, transport, and exchange data. Cloaking. That's key, because that stops hackers in their track. If they can't discover it, you can't hack it. And all of this enables this boundaryless networking that enables us to provide things like wide area microsegmentation. And to give you an example of some of the results, what some of our customers have expressed is that their time to provision now has dropped in order of magnitude by over 97%, because they don't have to touch so many distributed systems, and the complexity and also the fragility of that environment and updating it after the fact. It's simple point and click. What used to take network design of NATing and how it's going to fit in the NAT environment and the firewall rules and the port address translation and the interfaces to the remote network, what have you, all those policies and the design and the implementation and the review of them really start to dissolve. And it becomes, can I connect John Smith to the board of directors server and nothing else? And can I connect Steve in DevOps to instances in AWS and Azure that know no boundaries? It becomes point and click simple. The cloaking, our customers have estimated that in many cases, attack vectors, what were common attack vectors and worrisome, become eliminated up to about 90%. It's remarkable. If you are restricting down to the device level access control that has to be provable, it's based on identity, not an IP address, I start to change the game on what it means to truly segment. And again, it's not based on address defined or port defined. We can do that, but it's based on identity. The other benefits, more difficult to quantify some of them, but we fundamentally believe there's a significant reduction, and we've seen this in several of our customers' environments now, that we'd estimated about 25% in CapEx and OpEx, because I'm not having to buy as many different things as I did before. With the new HIP relay, why would you deploy a VPN when you could get wide area microsegmentation that was end-to-end? Why would you deploy a next-gen firewall deeper into the environment that still had to be policy managed based upon spoofable addresses? when I could do it based upon explicit and provable identity. And I'm not having to touch so many endpoints or re-IP devices in my network just so that they can be networked. The use cases go beyond what I showed you in regards to the example of wide area microsegmentation in regards to very sensitive data, and also wide area microsegmentation in regards to connecting distributed cloud resources that know no boundaries with DevOps, regardless of where DevOps resides. Again, the flexibility and the power to be able to create any type of segmentation without boundaries enables this type of previously impractical or next to impossible use cases. Everything from being able to instantly create micro failover based on instance type, not just across the data center, for example, or IoT, secure networking for any IoT element. That's one of our more common use cases among our customer base, especially given the fact that a lot of our customers have distributed IoT elements that might be coming from an AT&T cellular network, a Verizon cellular network, an TELUS network up in Canada, and maybe even resources and connecting to resources at the corporate headquarters. All those previous barriers and complexities start to dissolve and become secure. This is why we refer to identity-defined networking as networking secured by default. To learn more, we encourage you to not only go to our website, but send us an email. If you'd like a demo or you'd like to set up a conference call to explore some of the use cases in your environment, we're really not interested in pressuring anybody or anything like that. We simply believe the time is now to change the game against hackers, to simplify networking like it's never been done before, to save people time, money, while increasing and improving their overall security posture. Read about HIP on the IETF site. It's just search for HIP if you want to understand it further. But recognize too, that is an open standard. The ability to orchestrate policy across these and have all the distributed HIP services is fairly unique, or is unique to tempered networks. And now with that, I'm going to open it up to questions for the audience. And if you have any questions, please, you can ask them in the chat, and I'd be happy to answer any of these at any time. And if we can't get through all of these, I will, we can send out a contact to, or an email answering the rest of them to the rest of the audience. So with that, one of the questions I had was, what is the latency overhead of the HIP relay? Great question. It really depends upon the deployment of the HIP relay itself. But let's say you had a local workloads on the West Coast, and you had your HIP relay deployed in the AWS West cloud, or the region, and it's going to be under 5 milliseconds. And we've had customers report that it was negligible. Now, this is one of the powers, though, too, of the HIP relay, because they can be clustered. And we have customers looking at creating clusters that would direct users based upon their geo-IP location, but also for data sovereignty. So you all well know that the EU has certain data compliance laws and protection rules, not allowing data to leave Germany, for example. It's entirely practical and possible to set up a HIP relay within Germany, or anywhere for that matter, and any German machines could be part of a group that says you're going to only use this relay, and you can only talk to other and exchange data with other machines within Germany. That can't be done. It's not practical to do in the traditional address-defined world, only the identity-defined world. So the latency question is all about where you deploy this and how close to the workloads, but you could deploy it in multiple clusters and regions for not only performance and availability and optimization, but also for data sovereignty. I got another question here. Does the cryptographic identity leverage DoD PKI NPE certs? We do use self-signed certs, but the cryptographic identity is born when a HIP service is brought up. We're not PKI in the traditional sense, but because there's so much complexity associated with that. However, the way we behave is very much like that. And interestingly enough, within the DoD were the main sponsors originally of the HostIdentity Protocol. They knew in order for secure communications, there needed to be an alternative, some type of shim with traditional TCP/IP, but that would be compatible with all IP. So the DoD was actually one of the major sponsors in and behind and actual users of the HostIdentity Protocol. So think of the cryptographic identity bound to a unique cert that is then managed within the policies, but it stays with that host for the duration until you either revoke or disable or remove that host from your identity-defined overlay. It says, if you're reducing the attack surface by 100%, how do you account for phishing attacks, insider threats, etc.? Great question. By the way, I didn't say 100%, I said 90%, and it's the attack vectors that we're restricting. So here's how we do this. We won't do anything for if a machine gets compromised, for example, with malware. But because of our explicit segmentation, you've got incredible containment. First of all, if that machine is only authorized to talk to, say, 5 others, that instead of 100 that might be on the same subnet, you've contained it, right? You've reduced that. The second element, though, is that if a HIP service is either on that machine or in front of that machine, and it is not authorized to speak to anything other than what you have told it, we can, in essence, eliminate malware command and control because it's not an authorized outbound connection. So it would disable the ability for a hacker to get command and control of that machine. So think of a finance server, let's say, that somehow got it infected, and maybe it was physical, but if we were present, it would be extremely difficult to get in there and laterally move. But if it were, and it wanted to connect outbound to a resource, say in Russia, that wouldn't be allowed because it's only authorized to talk to the 8 other people in the finance group. So that's the degree of containment we offer. But again, to get penetrated in the first place, you know, phishing, if somebody clicks on a link with inside an email and they get, you know, malware is installed, we don't do anything for that. That's for endpoint security. But what we do is prevent the lateral movement of that to other systems, sensitive systems in the environment, and keep it from propagating widely. So the other thing too is, do we do any integration with network and security analytics products? And yes, we have an open API, and this is perhaps one of the most powerful elements. If you're using Splunk or ArcSight, or if you're using FireEye and you've got some threat intelligence and you want to lock down a machine, the revocation, that's one simple API call, revoke, and that thing won't be able to communicate to anything within the fabric. It's instant and it's irrefutable. It's not repudiated. How do you do key management with self-signed certs, enrollment, escrow, revocation? Again, think of it as this way. When a HIP service is born, it's brought up for the first time, and you point it to the conductor or orchestration engine to register itself. Say, here's the URI, here's the port I want you to communicate over, and that's it. It's going to register its unique cryptographic identity to the conductor. The admin, you can either have set up smart device groups based upon the attributes of that device, or the admin can manually say, yes, this device I'm allowing, and I'm going to put it into this secure network overlay. That's about the degree of the device or the certificate management. It's not we're managing certs, we're managing devices based upon their identity. And again, it's part of that HIP service itself. That unique cryptographic identity is part of the HIP service itself. There's nothing you have to do to install identity or certs or maintain those things on that device. It's when you license our technology and you're authorized for, say, 100 HIP servers, and it brings up each server and those get registered. Now I can set the policy based upon those host identity tags and the cryptographic identity of those things. So with that, we're at the bottom of the hour. If there's any other questions, please ask or continue asking if you want, and we'll send out an email with the answers to those questions as we communicate with you after this webinar. But I'd like to thank everybody for joining, and please reach out to us if you'd like to get a demo or discuss your own use cases and the potential applicability of identity-defined networking and wide area microsegmentation. So thank you very much. Take care. Bye-bye.